All right, seventh grade, we are checking out topic 11. So we're going to be studying circles, and I know you've already gotten a start with some background knowledge and looking at some different measurements we can take of circles, including circumference and area. So today in 11.1, what we're going to be looking at is just developing a good understanding of what a circle is and some of the different vocab that goes with it so that we can quickly and accurately make measurements of circles. So our learner's question for today is, how do I use the radius and diameter of a circle to make measurements? So we're going to explore some of this today in our notes, and tomorrow we will do a circumference activity that will let us dig into this a little more. So the first thing that we've touched on a little bit is the actual definition of a circle, and this might be helpful to you on your vocab sheet. But a circle is actually the set of all points in a plane that are the same distance from a given point called the center. So this circle is actually made by an infinite series of points that are all the same distance from the center. The center of this circle is called P. So we would call this circle P. That's how we name them, is by their center. So this circle is made up of all of the points that are exactly the same distance from P. So we have two different measurements labeled then, and I'm going to clear these circles to clean it up a little bit. So we have the radius, which you can see starts here in the center, and it extends out to the edge of the circle. So this is the distance from the center to the edge of the circle. And then we have the diameter, which is the distance going through the center, but it's the distance all the way across the circle. And we're going to use the diameter, this distance all the way across, for some things, and for others, we will use the radius, which is just this distance from the center out to the edge. So you'll notice that it would take two radii, which is the plural of radius, to make one diameter. So the diameter is twice as big as the radius, and the radius is half as big as the diameter. So the other thing that we need to know as we are moving forward with circles is we need to know a little bit about line segments. So when we talk about the radius, I'm talking about this line segment. It has a definite beginning and end. It starts with a point and it ends in a point. So it does not extend on forever in both directions like a line. It's a segment. So it has two endpoints. So I would read this AB with the line over it, I read that as segment AB because that line tells me that this is a line segment. So this diagram down here shows line segment AB, it shows line segment BC, and it shows line segment AC. So if we want to refer to the length of a segment, then we write the letters without the segment bar over it. So AB equals 3. Whenever I'm telling you what it equals, I don't need that line. So I could say AB equals 3. Or if I want to refer to the segment itself, I'll put the line over it. But you would not see this. Line segment AB equals 3. So let's see why that matters and how we're going to use these. So let's look at this example over here. We have a logo that an art class has developed to represent the school in their art show. We need to determine which of these segments are radii, which again is just the plural for radius, and which are diameters. So radii would be any that start in the center, and a diameter is going to start at one edge and go to the other edge while going through the center. So as we're looking, I'm going to start at point P because I see line segment PA would be an example of a radii from center to the edge. I also see that PD is supposed to be green, there we go, would be another example. I also see PB, line segment PB. Now I'm noticing this segment here, BD. It looks short, but this one does not start at the center. So BD would not be a radius. I have one more, however. If I start at the center at point P and go all the way out to C, line segment PC would be another example of a radius. The only diameter that I see that goes all the way from one edge of the circle to the other while passing through the center is line segment AC or CA. It doesn't matter in what order you name them, it refers to the same segment. So that's my only diameter, but I have 1, 2, 3, 4 radii. Okay, so let's take a look now. Go ahead and pause the video and take a second to decide how many radii you see shown here. And while you're working on that, I'll start labeling. You'll notice I've used 4 different colors to label the 4 different radii. We have OA, OB, OC, and OD. Let's look at this example. 2 radii of a circle that lie on the same line form a diameter. So you can see here that radius plus radius equals diameter. So the length of a diameter is twice as long as the radius. So we could say diameter equals 2 times the radius. And that's an important relationship we'll use when we're problem solving, like on this one. So the distance from a car to the center of the Ferris wheel is 221.5 feet. Approximately how tall is the Ferris wheel? Well, if this distance here from the car to the center of the Ferris wheel is 221.5 feet, then I ought to be able to double that to tell you about how tall the Ferris wheel is. Notice it says approximately because we don't know how much distance to add for the amount that it's raised off of the ground, but if I double the radius here, that will give me a good approximation for the height. So we can just double 221.5, which would give us 443 feet. So one example of how we can use the measurement of the radius and double it to give us the diameter to solve a real-world problem. In this diagram, ST is 4 1/3 feet. What is SO? So I know the whole distance, I know the diameter, and now I want to know just the radius. Well, I know that the radius is half of the diameter, so I just need to take half of 4 1/3. So to do that, I'm probably going to change 4 1/3 into a mixed number, or I'm sorry, into an improper fraction. So 3 times 4 is 12, plus 1 is 13. So I could rewrite this as 13/3, and if I need half of this, I'm going to multiply it by 1/2. So that gives me 13/6. If I want to change it back into an improper fraction for my final answer, I can. That would give me 2 1/6 feet for the length of SO. And for our last two, the expression 3x minus 1 represents the diameter of the orange slice. So that gives me the distance going all the way across. That distance is 3x minus 1. But what I also see is that the radius is 2.5 inches. So I know if I double this radius, that it should equal the diameter, right? So if I double 2.5, that gives me 5. So 5 should be the length of the diameter. And if this expression equals the length of the diameter, now I just have a two-step equation to solve. So to get x by itself, I'm going to add 1 to both sides. And now to get x by itself, I'm going to divide both sides by 3. And I find that x equals 2. And for our final problem, if Km, so I see that that's my diameter, equals 2x minus 4, and Lm, which is my radius, equals 12, then I want to find the value of x. Well, my radius, it will take 2 of those to equal my diameter, so I need to double the radius to equal the diameter. So again, I have a two-step equation to solve. So to get x by itself, I'm going to start by adding 4 to both sides. And now to get x by itself, I'm going to divide both sides by 2. And I find that x equals 14. You are all set to get started on your 11.1 digits homework. Good luck!